Hi everyone, my name is Nick Morales and this is my solar array design. Um, my project focuses on Kaiser High School in Hawaii Kai. Uh, I think it's a good idea to start with schools because they have a massive footprint and high energy costs, especially with air conditioning. Um, we are able to use Aladdin and perform a deep physics and building analysis, see if we can turn the campus into high efficiency decentralized power plant. There were three phase layouts to my design. The first one here is the primary generation source. We built the gym. There's some additional um, canopies on the side here that I wasn't able to really use with the program, but I could have got even more on top, um, more solar panels on top. And then this next phase here is the canopy array, and these were adjacent to some of the Kaiser solar panels, so they actually kept around the same degree. And then the last phase is a ground mounted array for the campus part, and I believe that's just across the street. And we put a tree shielded perimeter to address community aesthetics and public safety, hide some of the technical hardware from view while maintaining the park's visual appeal. The point of these simulations was to see how the Thevenin equivalent circuit can be modeled in each panel. That's it, a voltage source in series with a resistor. Um, Using the animated heliodon feature, this tool allowed me to measure this exact angle of the solar panel relative to the Kaiser specific coordinates throughout the year. Um, we compensated for shadows and different times of the year. So we ran a year long. And by running the physics across the year, we can compensate for the seasonal dips and ensure the system remains efficient even when the sun is lower in the sky during the winter months. So we're able to get more accurate prediction on not only how much energy we'll be um, we'll be able to generate, but when is the most important time to use that energy that we have stored. And if we see this figure here at the bottom, figure 5, that's the analysis of our data. The blue bars represent the school's actual energy consumption, while the green bars show you the solar yield. And you see much more green than blue. So I'd say we're in the positive at that point. And we saw its peak here, down here in August, and even when the heat is at its peak, the demand is and the highest. Our generation completely dwarfs what we need. So the consumption. So I think total annual yield is at 218,000 kilowatt hours, um, which is an insane amount. So I would say it was a success. My conclusion is that we definitely operate as a high efficiency decentralized power plant, and that's my project. Okay, thank you very much.